These are the examples for Geometry B, Credit 2, Lesson 11.4. Lesson 11.4, we're going to be discussing similar triangles. We're going to be discussing a method called angle-angle similarity, which is used to prove triangles similar, almost said congruent there. Let's explain the difference between the two before we jump into it. So when we have two triangles that are congruent, which these triangles here would be examples of, you have to use your imagination. I try to draw that as best I could, of triangles that are congruent. Triangles that are congruent are the same shape and size. So again, not only the same shape, but the same size as well. Now, triangles that are similar are still the same shape, but as you can see with these two triangles here, they are not the same size. And even though they're not the same size, in similar triangles, the angles themselves are congruent. That might sound a little confusing. Let's say that again. So in similar triangles, while the sides are not going to be congruent, the angles will be congruent. So for example, this angle here would be congruent to this angle here. This angle here would be congruent to these angles here, those two. And this angle here would be congruent to this angle here. Now, so you say, oh, so we just proved the three angles are congruent and then we have similar triangles. Well, you could, but actually, since in any triangle, or because in any triangle, the sum of the three angles is always 180 degrees, all you need is two of the angles. And the reason for that is because if two pairs of angles are congruent, the third pair has to be congruent since all three angles add up to 180 degrees. And so that's why we have angle-angle similarity, just two angles, versus angle-angle angle. All right, let's jump into the examples. This first example here is for both problems 1 and 2. And the question is simply, are the triangles similar due to AA, or angle-angle similarity? Well, let's take a look here. The first thing we notice is that, and let's make sure we understand what the two triangles that we're talking about are, because what we have here is one triangle, this little triangle BDE, on top of the bigger triangle BAC. And so again, we're trying to say whether or not the two triangles are similar. Well, let's notice here, both of these angles here have a measure of 53 degrees, so they are congruent. So we could say angle BED is congruent to angle BCA. So that's one of our angles. Remember, we're dealing with angle-angle similarity. So that's one pair of angles. So we would need another pair of angles to be similar in order to show angle-angle similarity and to say that these two triangles are similar. Well, it turns out that the two triangles share an angle. This angle B here is part of the little triangle and it's part of the big triangle. So we can say angle B is congruent to, well, angle B. It's congruent to itself. And while that sounds a little silly, we actually have a term for that called the reflexive property. And so this angle here, now we don't know its measure, but it's the same angle in both triangles. So it would be, of course, congruent to itself. And so since we have two pairs of angles that are congruent, we would say, yes, these triangles are similar by angle-angle similarity. Now, a word of note here. Now, regardless with this diagram, we have this angle that is shared by both triangles. Angle B is congruent to angle B. However, if we were to change the measure of one of these angles, so let's say instead of 53, we were told that this was 48 degrees. And so now we lose BED, angle BED, being congruent to angle BCA, and we no longer have that. If that was the case, then we would have answered no, the triangles are not similar due to angle-angle, because we only have one pair of angles, angle B being congruent to angle B. We only have one pair of angles that are congruent. But as it was in our example, we had 53s, so this is, well, I shouldn't have crossed that out, but this is valid, and so we have two pairs of angles that are congruent, and so we would say yes. All right, so that's the information, and those are the examples, or for problems 1 and 2. Now moving over to problem 3, it says find the value of the variable. So what you have to picture here with these triangles is not, so we have a triangle here and a triangle here. In order to figure out which sides correspond to each other, what you need to know is in order to map or to see what corresponds side to side with the triangles, we're not flipping the triangles here, but rather we're rotating them. And so this angle, this triangle, this triangle here would be, or this angle here, excuse me, would be congruent to this angle here. And so, and of course that would be because we have parallel lines and alternate interior angles are congruent. So the way we would set that up is we'd have 8 is to x, because again, this corresponds with this. And using that same left to right thinking, we would have 8 is to x as 12 is to 33. Notice we go in the same direction both times. So 8 is to x, and then as 12 is to 33. All right, so remember when we have a proportion, which is just two fractions that are equal to one another, we cross multiply. We have 12 times x is 12x, and then we have 8 times 33 going the other way. 8 times 33 is 264. And then the last step to solve for x is being multiplied by 12, so we divide 12 to both sides. And we divide 264 by 12, and it turns out that x is 22. All right, so that is our example for problem number 3. And now moving over here to problem number 4. Once again, and just double checking, making sure we have all the numbers correct. We do. So once again, the triangles don't flip, but rather rotate. So again, this angle would correspond to this angle. So these two sides correspond to each other. So we would have 38 is to x, or 38 over x, equals, and once again, we're going that left to right. This triangle, then this triangle. We have to go in that same order, or we won't be setting this up correctly. So if this is if this side is in the numerator, this side has to be in the denominator. Or I'm sorry, this side's in the denominator. Likewise, this side's in the numerator, and this side's in the denominator. All right, so we cross multiply. We have 8.4 times x, which is just 8.4x. Going the other way, we have 38 times 29.4. Simplifying on the right-hand side, 38 times 29.4. We have 1,117.2, multiplying this here. All right, our last step to solve for x is being multiplied by 8.4. So we divide by 8.4 to both sides. And we divide 1,117.2 by 8.4. And we get 133, our answer for x. All right, so that is our example for problem number 4. And again, a couple things to keep in mind is that, as we said, for both 3 and 4, is the way we map one triangle onto the other is that we're not flipping, but we're rotating. And so this side corresponds to this side here. Imagine this triangle rotating, this side rotating up to here like that. And then also, if we're going to put this side in the numerator, in our first fraction, we have to put this side in the numerator in our second fraction. So consistency is the key. 38 over x equals 8.4 over 29.4. So again, pause, rewind the videos, making sure that you understand that. And it's always nice to have it on video, right? Because even though it's a race now, you can always go back a minute or two to see that. All right, so now what remains is our examples for problems 5 and 6. So for problem number 5, we have this triangle here. And let's go ahead and draw this. We have 12, we have 18, we have x, and we have 50. All right, what they want us to do is solve for x. And so remember, in our similar triangles, I'm not sure if we mentioned this before, Of course, the angles are congruent. The side lengths are proportional, as we saw in problems 3 and 4. All right, so let's go ahead and take a look here. Now, how do we set this up? Well, our small triangle is here, and of course, our bigger triangle is the whole thing. So we have 12 is the length of this side here. Now, a common mistake or a common misconception, let's move this over just a little bit here, is that the length of this side in the other triangle is 18, but it's not. The length is this entire side here, so we need to add this up. 12 plus 18 gives us 30. So it's not 12 over 18, but 12 over 30, because again, we want the length of this entire side here. So the 12 plus the 18. Now with the other sides, it's a little bit easier. This is X. And notice we're going little triangle to big triangle, 12 over 30. And then same thing with these sides, X over 50. All right, so now, once again, we have our proportion. And again, to make sure you have a good understanding, pause, rewind the video to make sure that does make good sense there. So we have 30x, 30 times x is 30x. Going the other way, we have 12 times 50. And then 12 times 50, we multiply that out, and we get 600. And then our final step, x is being multiplied by 30, so we divide 30 to both sides. And 600 divided by 30, that gives us 20. So our answer here, x, the base or bottom of this small triangle, has a length of 20 units. All right, now for our final example, for our final problem for number 6, we have another similar situation, no pun intended, talking about similar triangles here. So let's go ahead and set that up and get a little more practice with this here. All right, so this time we're solving for the bottom side or the base of the bigger triangle. This is, that's, let's see, we have, nope, this should be 30. And this is X, this is 25.6, and this is 38.4. All right, so once again, setting up our proportion, we're going to go small triangle over big triangle. So we have 25.6 over, now remember, not 38.4, but the entire length of this side. So we need to add those up. We add 25.6 and 38.4, and we get 64. So the length of this entire side here, which is the length of this side in the big triangle, is 64. And that's going to be equal to the length of this bottom side in the little triangle, 30, over the length of the bottom side, which is represented by X in the big triangle. All right, so now we're ready to cross multiply and solve. 25.6 times X is 25.6X. And then going the other way, we have 30 times 64. Or 64 times 30. Remember, the order you multiply does not matter. That's the commutative property. We bring down our 25.6x. 30 times 64 is 1,920. And then for our final step, x is being multiplied by 25.6. So we divide 25.6 to both sides. And the 25.6's cancel. We divide 1,920 by 25.6. Remember that fraction bar indicates division. And we get 75. And so our answer for our final example is 75 units. All right. So once again, pause, rewind the videos. A few little things going on there, but definitely something that you could master and manage with just a little bit of effort there. So good luck with the work. And again, pause, rewind as needed. And until the next video, take care and God bless.